set this up. Okay, it's perfect. Good. So let's start again with let's say the easiest. The easiest one is this, only because this is a straight line. And I'm going to say that the slope of this line is kind of 1. You can say no, for me it's 2. Well, then it's, if you want, but I think it's okay to consider it 1. What about the slope of this line? Well, it appears kind of like -1. And here, again, the same slope. They appear to be parallel. So I'm going to say m equals 1. But there is a corner here, and there is a corner here. So therefore, this function cannot have a derivative at this point. So I'm going to graph it here. At this point, and at this point, the function cannot have cannot be differentiable. So in other words, the derivative has to have a jump. So this is +1. This, as I mentioned, is -1. And this is again +1. So this is the derivative of this function. Is this okay?
Yeah, that makes sense.
Perfect. So this is the easiest because it's composed of lines. That's why this is the easiest. Okay, let's continue with this one. You understand why the coordinate system has to be exactly below the functions so that I can show that these points are here and this point is here. So that's why I will try to present this one here. So number 3 is over here. Okay. So positive, huge, positive, smaller, positive, smaller, positive, smaller, 0. So positive from huge to 0. Again, here is 0. And on this side is negative, negative, negative to huge negative. So this has to be this way. Now let's see in the middle. There is a 0 again. So this is a point on of the derivative. So now from 0, it starts decreasing till a max point in the negative sense. And then it's still negative, but now approaches 0. So something like this. It shouldn't go that far. It has to be a smooth function. Okay, so I'm going to make sure that this is gone from there. Okay, on the other side. So it's positive now till a moment where it's huge, and then it gets smoothened to 0. Huge, back to 0. So the derivative of this is here. Is this better?
Yep.
Okay. So now let's go to,
so
yes?
Just to check real quick, when it's a point, it doesn't exist. You have to do a jump. But when it's a curve, it's 0.
When
the derivative.
When I say this is huge, I mean the slope of the tangent is huge. The slope of the tangent is smaller, but positive. The slope of the tangent is smaller than here, but still positive. And then the slope of the tangent is 0. I graph here the slope of each tangent.
Yeah, I get that, but like comparing this graph to the graph above that you did, where it had the sharp point, that point is a jump, not a 0. Like the derivative of the
But we know that this is a corner.
Yeah, the corner.
A function is not differentiable when it has corners because it has 2 tangents. So when a function has a corner, at that corner, it has 2 tangents, one in this case positive and one negative. So therefore, its derivative is not defined and it has a jump in this case, but it's not defined. In this case, it happens because it's positive and negative, so it has a jump. So for corner and for cusp and for vertical tangent. In all these three situations, the function is continuous, but it's not differentiable.
Okay.
Is
Thank you.
that better?
Yeah.
Perfect. Okay, so for A, again, I established the zeros. And then huge negative, smaller negative, smaller negative, smaller negative approaching 0. So from huge negative to approaching 0. Then positive, and then positive, huge positive. Huge positive, it's a maximum here. So I didn't graph it correctly. So this is yes, that's fine. It's correct. A maximum. And then smaller and smaller approaching 0. Yes. And then here it becomes negative. Small negative, bigger negative, acute, more acute, bigger negative, huge negative. Slope, almost vertical, almost, of course not. So this is here. Now the last one. Again, I will establish the zeros, if any. Yes, it's right here. So there is a 0 at 0. Now, so let's analyze it. So the slope is almost 0, but not quite, and it's negative. Negative, big negative, this is the biggest. This is the biggest negative. And then smaller negative approaching 0. So from approaching 0 and negative to a huge negative and then approaching 0. On this side, positive, huge positive. And then smaller positive approaching 0. This one is here. It's not an easy situation, I have to agree, to come up with this. Are we okay now? I let you match them. Do you still need me to match them and look at what they have in there?
No, I just want to clarify. So when the original graph is having that bottoming out, does that mean that's when the derivative is going to be crossing the x-axis at 0?
Because it has a maximum or a minimum.
Okay.
Here I'm graphing the slope of each tangent that I graph. So here the slope of the tangent is 0. At 0, the slope of the tangent is 0.
Got it. Okay.
Here, the slope of the tangent is 0 is at this point. Here, the slope of the tangent is 0 at this point, not at 0. Here, the slope of the tangent is 0 at 0. Is that better?
Nice, it is. Thank you.
Good. So are we okay now with their graphs? I'm going to post both these. Anything else you would like to go back to? Anything? Any problems? Anything? Anything? Anyone would like to start with any question? So these are my the papers for group notes. So I need my nice papers for lesson. Okay, I'm ready. Anything you want to start with? Anyone?
I had a question
Yes,
about
I'm ready.
one of the homework problems.
Yes, I'm ready.
Number 32 from 2.8.
Do you have it or do I need to look it up?
I think I have it. Oh, I've been logged out.
That's fine.
I think it was just find the tangent slope of 1 over 1 plus x square root of x.
He's right. It's g of x equals 1 over 1 plus the square root of x.
Like this?
Correct.
Yeah.
And the point?
There's no point as far as I remember.
There's no point. They just wanted us to
Just find G prime?
correct.
Yes.
Okay, very good. So please remember the definition. The definition has two concepts that we've been looking at for a long time. The concept of LIM and the concept of the difference quotient. This is the definition of the derivative. The limit, of course, when h approaches 0. So, limit as h approaches 0 from g of x plus h minus g of x divided by h. So, in the next step, I will write one comment I have about the notes from last time. When you write limit of x plus h plus 2, I don't know, when h approaches 0, if you omit parentheses, then you are only applying limit to x, not to x plus h plus 2. So please remember, you need parentheses. It's like me telling you the square root of x minus y plus 2. And I want you to understand that actually the square root goes all over. But if I only put it on the square root of x, how will you know that it goes all over? It's the same idea. So if you have the limit on x and you do not have parentheses, then the limit is only on x, not on the whole thing. So please pay attention to that. Okay, thank you. So limit as h approaches 0 from 1 over 1 plus the square root of x plus h minus 1 over 1 plus the square root of x divided by h. What will be the next step here? Anyone?
These are the denominators and the numerator.
Exactly. Once I found the least common denominator, that will be my next step. So what could be the least common denominator here?
1 plus x plus h squared times 1 plus square root of x.
Of course, because they have nothing in common. Okay, now, of course, remember the adjustments. I know many of you were taught to multiply both top and bottom. I'm fine with that. The method is fine, but it can get hairy at some point in time. That's why I don't present that method. But if it works for you, it works for me. I'm fine. So this is 1 plus the square root of x, and this is 1 plus the square root of x plus h. Is this okay? We understand what we just did, everyone?
Yeah.
Okay, so then in the next step, I have 1 plus the square root of x minus 1 minus the square root of x plus h. Luckily, these two go away. And this is h over 1. I'm going to flip. So this is limit as h approaches 0. H, 1 plus the square root of x, 1 plus the square root of x plus h. And the numerator is the square root of x minus the square root of x plus h. So what I didn't say, and I want to go back and say it, this is definitely 0 over 0. And as we know, a lot of simplification has to happen, and when I apply the limit, I'll get a function. And the function will be the derivative of this. The rate of change of this function at any point where this is differentiable. Okay. So, of course, this is still the 0 over 0. Let's check. So when I have h equals 0 here, I don't care what these do, right? So when h approaches 0, this is 0, and when h approaches 0, this is 0. So obviously, I'm in that situation. These are friendly. This is no threat. It's 1 plus the square root of x. When age approaches 0, who cares? This is no threat. This is no threat. When age approaches 0, this is 1 plus the square root of x. No threat. This is the threat. This is what I want to get rid of. And of course, the numerator shouldn't be 0. Okay, so what is the next step? So see, because these are constants when it comes to age approaches 0, you can even put these two in front. I don't care if you do that. It's allowed. You can put them in front. Apply the limit here, and these two are in front as constants, so to speak, when it comes to age, because they don't have age in them. But let's continue. What do we do in this situation? Always.
I'm blanking on the name, but I think it's the consonant you multiply by that, which is the square root of x plus x plus.
Thank you so much.
the square root
Exactly.
of
We
x
rationalize. Rationalize. Good. So I'm going to multiply. I'm going to be lazy and multiply by the square root of x. Oh, this is no good anymore. It's gone. Plus the square root of x plus age, the square root of x plus the square root of x plus age. This is not a friendly problem. I have to agree. Don't forget the limit operator. We did not apply it yet, so you cannot drop it. So limit as age approaches 0. The denominator is humongous now. Age, 1 plus the square root of x, 1 plus the square root of x plus age. Watch me run out of room. Square root of x plus the square root of x plus age. I always do, almost. Okay, now the numerator is nice and easy. These two go away. Do not simplify here, please. No matter how lazy we are, we have to write it one more time. So this is limit as age approaches 0. The numerator is negative age. This is the culprit. This is the problem. This is what I expect to get rid of, because this creates the 0 over 0. Once this is gone, then the limit exists. Okay, so this is gone, 1 and 1. Now I drop the limit operator because I apply it. Negative, the numerator is 1. Can anyone give us the denominator?
One plus the square root of x squared times 2 square roots of x. I think.
That's it. Because this approaches 0, the square root of x plus the square root of x is 2 the square root of x. These two are the same when age approaches 0. So we can rewrite it nicely as 2 the square root of x, quantity 1 plus the square root of x squared. This is not a problem for a test. It's not suitable for any test or final exam. This is to enforce the and understand the concepts and get faster and better. This is not a candidate for a test question. Absolutely not.
So kind of going off that, what is the test going to